this is sort of for them. So a lot of us, this team that sort of got together, we all came from like retail backgrounds, food service backgrounds. These sort of like higher visibility jobs that, you know, like you're a cashier, you're a stockbroker, right? There's a lot of call-outs as well, you know, it's a big problem that actually caused another issue for the people who are already on the floor, who are already in the kitchen, who are already in the breath. And so because of that sort of direct involvement, we decided that we were going to all come together and build what we now call Associate. And Associate is basically a platform that helps you dynamically fill shifts based off of whether you're food service, whether you are retail, whether you're hospitality, whether you're manufacturing. Is sort of where we've been targeting recently. And you know, if you're calling out due to sickness, that's one thing. If you're calling out due to something else, that's all, you know, unplanned absences that definitely affect your sort of operational workflow as well. And so we created this to basically within 3 clicks, or what we're sort of engineering now is a voice prompt to go ahead and basically find the next person who is able to qualify for the shift. So you can see here, it's actually a quite quick process here. I didn't have time to set up some demo branch locations, but you can kind of imagine how that works. And especially if you're like a big enterprise level and have a lot of stores within the same area, that store density, why not take a person from another store and plop them in another one, right? So that's sort of the underlying thesis that you're doing. So go ahead, right, and go ahead and immediately submit, and we're done, right? No problem. So that's sort of startup there. However, I also started working on a sort of side project to this that actually helps me perform a lot of my administrative sort of like sales and operational sort of busy work, if you will. And I'm pulling this pretty well. And essentially what it is it's a AI workspace. And my whole goal is basically to take everything that I've learned working with AI tools in the past and make it a very, very incredibly simple process that allows you to just get up and going within minutes and start experimenting with these sort of agentic systems. But what a lot of the hype is right now, I've just noticed that there's sort of a unexplainable way that a lot of big, especially enterprises that are producing agentic solutions, are bringing these things to market, and I wanted to simplify it. So sort of getting into the meat of the demo here. This app is sort of what I call project-based. And the idea here is that whether you're running one project or you're running many, you should be able to interact with and interface with what I call a single input model, right? This is not a bunch of different configuration screens. This is not a bunch of, go here, go to that platform, go to that platform, go to that platform, like I see a lot of other enterprise things. What I'm trying to do here is I'm trying to make it quite literally interact with that one. That's it. Because that's how it should be. So I like to call it sort of the project focus. And what project focus means is that I can have a bunch of different projects running at the same time, right? So I can have sort of my main thing, I can have even a pickleball hoop right there in the middle. I can have my personal projects, everything that I need to keep track of, all in one place, right? And you can see here, right? All of these have their own sort of interfaces here with their input bars, but you also have it at the project level. So I don't have to say, I don't have to even go into a project, right? I can be sitting at the top level and I can say, hey, what's going on in this thing? They'll tell me exactly what I need to know. So that's a little bit of a project switching. You can see like here I have one for like something, or this is a fake company. I set up a fake company for this. Not registered. You get what I'm saying. And so this is like a pre-report. This is like a manufacturing company. I have one that's the pickleball league that is something like this, and then I have one that's more like personal. And so these are all from sort of the same unified interface. What I will do now is I'm going to actually go into a couple of these, and I'll kind of show the main functionality and how this all works. You'll see that there's sort of two aspects of this, right? So you have like the main workspace where you can coordinate a lot of this stuff, but you also have your administrative sort of stuff, like your admin concept. This is what allows you to get sort of the reliability, or to ensure the reliability of your agent agents or your agentic system, but also the observability, and that piece I want to show because I think is important, especially as we talk about things like security and governance, and a lot of these things that I think used to be a lot more complicated than we really needed to make them. But yeah, so let me go ahead and just show here. So I have a few databases here in my viewfinder. And again, like you can see, like this is just admin console, and I have a bunch of different agents here at once. And each has a very specific things. This isn't just agentic workflows for like, okay, this specific task, that specific task, that specific task. That's what jobs are for, right? Then we can actually organize very leanly organized agents to do something very specific. Or like these like workflows that we used to kind of just isolate as different sessions, right? So let me go in here. So this is kind of main agent here, and then I have a database agent, and I can sort of see what's inside it. Designed to be as quick as possible to sort of access what's going on here. You can see here I got some order data, right? Because this is a manufacturer for Intel. Probably have some orders. And you can see here, right? Like I can see all of what's going on here, all of the orders. And so, for example, if I go back up to the main sort of orchestrator agent that's handling all of these sub-agents, I can go in and I can say, what were my last two agents? Or sorry, the last two orders. And so the orchestrator is going to think a little bit. It's going to reach out to our SQL database. Hopefully, God's on my side, it's going to show us the order. This is simple rendering, right? This isn't quite anything new. But what I wanted to do on top of this is sort of show the observability aspect and sort of the advanced debugging. So you can see here it shows me how long it's going to execute, how many credits at the sort of pre-Go AI platform level is still. And it also shows me the exact step-by-step breakdown of what the sort of orchestrator model is doing, what the SQL model was doing underneath, right? You can see all of these things. Yeah, so that's kind of how that looks as of right now. And another thing that I try to do on top of this, right? So we kind of talk about security, we talk about observability. I can go ahead in here, and I have my order state. I can go ahead and hit edit restrictions. I can hit a customer name as a column, right? So you can see now that entire column is red. Hit save restrictions. Hopefully that's safe. Yep. All right. So I'll go back and I'll say something like, what was the customer's name for order item 3? And so what's happening in the background is a series of redactions based off of what's happening. The idea is very like zero trust and low trust to the underlying LLM involved, so that this can work with whatever model you choose to plug and play, whether it be Claude model, whether it be one of ChatGPT's models, or OpenAI's model. But you can see here that it intentionally actually avoided our customer and gave me everything else. So that piece there. So the redaction is actively happening in the background. We'll go ahead and disable that. So that's sort of like a zero trust aspect to agentic systems. Now the other thing I want to sort of show as a result of this, right, is we can chain agents together. Again, nothing new, but the observability piece I hope to sort of bring more to light. So I can go in here and I can say organize let's do it a little bit differently. Generate a pie chart visual of my orders organized by steps. And what will happen here now is now the orchestrator is saying, hey, this is an advanced tense. Right? Now I'm not looking at just a SQL database supporting information. We're also looking at, or piping whatever came out of it into the visualization agent, which is here on our panel here, visualization. You can see here that it actually goes and generates our chart based off of all the data that we've been talking about. Right? So that's sort of like your chaining effect and how you're able to combine these things to work together. Now, yeah, this is just sort of demo information right now, but this is something that I will actively even use to like track leads, actively use to track like prospects with our sort of main sort of product. Yeah, I think the other portion that I wanted to show, because I know I'm running a little bit low on time here, but sort of bringing that back to the workspace, right? So I should be able to ask the exact same question from something like this, right? So generate a method. And I would not even have to touch the administrator panel to interact with any of these, right? The administrative panel is just for observability. That's just for security. That's just for sort of your high-level administrative activities. And let's say you wanted to bring in like a bunch more people to get involved with this, right? You wanted to bring on other roles, right? You wanted to bring on like a sales manager. You wanted to bring on people that need access to the same sort of workspace or team environment. You can include them in this, and they can just see it the exact same way. No access to that. The other thing is, and I guess I'll kind of just overview like the things that I can't demo, unfortunately. I wish I had more time to demo. But the ability to create intake forms. So with one prompt, you can say, hey, I want you to generate me a table and also create an intake form, which then would actually generate that intake form, connect it, map it to your database columns, and then give you an embed link. And you could even give that embed link to Claude Code and say, hey, throw this into this page, right? Up would generate a page with that intake form. Some of the details, and you're up and running within like a minute, right? Versus having to do all that engineering step by step by step. It's going to be a wild kind of era for AI, and I know that this is sort of still even scratching the surface of what's possible, just based off of sort of what I understand to be out there. Kind of that expression of like you don't know what you don't know. I think that's going to be especially true. And I will take another minute just to say the fact that like I think that the age of AI is going to change a lot of things. It's going to produce, frankly and unfortunately, a lot of layoffs. And I think it's sort of our responsibility to inform the rest of the world and bring it to their attention that if you're doing sort of mundane tasks or things that are highly repeatable, it's time to sort of learn where the human nuances are, right? What is something that you uniquely understand that others might not necessarily, right? Because a lot of your future value will lie in being able to understand that issue specifically, and then also be able to actually actively do something about it. We live in the best age to actively do something about it. So I have a little bit of I hope to kind of leave it on a positive note and sort of an uplifting note, and I think we have the potential to really make things a lot better, a lot easier. So with that, I thank you all.
Any questions for Anton? We've got time for questions.
Got some source shoot suggestions.
Yeah.
I have really good questions first though. But I bet it would be helpful to have like a almost or a graded notion of whether or not somebody is available. Because if I'm a manager and I got to cover 8 hours all of a sudden, and there's somebody who can make 7, right?
Yeah.
Not the 8
Yeah.
hours.
Fractional. Yeah.
Yeah, like that. I would want to know that.
Yeah.
And the other thing is the really natural integration there with third-party temp services. Like you can make that happen.
Yeah. No, definitely great thoughts, and we'll take that offline too. So thank you for the network. Anything else?
So where are you hosting it?
Exactly.
Where are your servers?
Different services for different elements of the projects, but mostly AWS is consuming a lot of our backend functionality.
All right, thank you, Anton. And you're part of too, right?
Work with them, Freedom us.
Some good startups coming out of Oregon. All right, up next we have Sage Faraday to talk about some autonomous swarms. Sage was one of the first people I met when I became a little startup person in Minnesota. We met at Startup Week. Now you're an engineer at Rosenblatt. You were an active military member. Or you used to be in the military, I should say. Just an awesome leader in our community and really awesome posts on LinkedIn, and recommend a good follow, especially if you want to get in touch with some more of the technical aspects of stage.
It worked. Hello, everyone. I'm Sage Faraday, now a partner at Rosenblatt AI, so I got some of that sweet equity. I've been kind of also the CTO at Rosenblatt AI, and to explain what Rosenblatt AI is, it's essentially an engineering services firm that is attempting to iterate on itself and figure out how do we do engineering with AI. So I'll be going into a little story shortly about to kind of help put into perspective like what it means to iterate on itself, and also kind of what makes Rosenblatt itself especially valuable. We work with a lot of different startups. We've also worked with a couple big market companies to come in as like senior engineers, team leaders, sometimes fractional CTO work to kind of help lead their AI engineering efforts. And so as part of that, we also do R&D internally. So it's a kind of a weird situation where we have product companies that are doing services and service companies that are doing products. And we're a service company that's working on an internal product, essentially. It's a sort of platform that we like to think makes Rosenblatt engineers more competitive than they would be if they were not at Rosenblatt. So we have an internal kind of AI engineering platform, and part of that, in this case, is what I like to call the swarm, the AI swarm. So I'm curious if AI swarms have been on your mind, like raise your hand. Okay. Are AI swarms essentially a priority? If you've heard them be mentioned, so essentially an AI swarm is like a group of AI agents that's working as a team to accomplish like a single task.
How many qualify as swarm?
More than one. So I know Claude Teams, for instance, or Claude Code has teams of agents that you can spin up. That's like a small version of what I'm talking about. For this example, I have approximately 6 agents running in parallel. So I guess I'll go ahead and just kind of jump right in. And I should probably introduce myself. So yeah, I'm Sage Faraday, former military intelligence, used to read 4-star general at Paycom. Ended up having to retire early for medical reasons. Now I'm helping Rosenblatt specifically with their engineering work, and I've been doing engineering for about 10 years. So that's my super quick synopsis. I joined Adaton, which is a startup, a couple of years back. That's where I learned that I really enjoy working at startups. And now their apps are on aircraft carriers. So had some pretty fun moments. It's also a volunteer on a particle accelerator for 2 years. I got a research paper out of that. I was a co-author on it, so that was also fun. So that's a little bit about me. I get all of it. So to talk about swarms in this case, here's our numbers. So we went from about 40,000 in revenue 2 years ago to about $1 million in revenue last year between all the folks we've been working with. The startup clients we've worked with have raised about $3 billion, and we've been a little bit of a part of that. They're the majority of that. We just kind of enable their like seed round, Series A, things like that. Help be like the senior technical person. They've also had $1 billion raised from completely new MVPs that they've helped build from the ground up. And then on average, we try to do about 4 weeks to get a production launch with whether it's a pilot with an enterprise or a mid-market company or an MVP with a startup. Because we are big fans of putting things in front of users as soon as possible and acknowledging that at the start of our project, we know the least about the project, like what a successful outcome for it looks like. So yeah, for today's presentation, I wanted to talk about one way we've used swarms recently, which was, and I've used an example application here just so there's no API issues or anything like that. Essentially, to migrate an app from Lovable to AWS in a single button click. So that's the goal for this particular Swarm example, and I kind of managed it, but there were some kind of deployment issues over on the AWS side, and I'll kind of talk about why that's an interesting starting point and where we're going to go from there and how our Swarm actually works. And because once it's gone through that whole process of migrating something from Lovable to AWS, that's just like the beginning of the journey. So in this case, it was called the triage application. It's basically a simple application that tracks bug tickets and things like that. With Swarm, our goal is to have each one of our team leaders essentially have their own Swarm that operates underneath them. And each one will have like a lead orchestrator that they work with, as well as different specialized agents for different tasks. So this kind of gives you a high-level overview of it. But one of the unique ways that we've set up our Swarms is they're actually able to kind of groom their own skills. So as they encounter errors with the way that they're doing things, they will actually store it permanently in memory or some sort of skill. Or we also track every turn of every kind of every tool call, all of that. All of it becomes index searchable session history. So it can actually search back into the past and say, oh, I worked on this project over here and ran into this problem, and now I can apply what I learned there to this project that I'm now working on. Or maybe this is a common problem. I'm going to store this in my skills so that I can apply that skill to this common problem quickly instead of just burning tokens and trying to solve the same problem over and over and over again. So that's kind of a high-level overview of what we're doing internally. And you can also kind of see why that would be interesting from a perspective of us as an engineering services firm helping clients do engineering, because often we come in almost like forward-deployed product engineers. Like we care about the outcomes first, then we work back from there and we see if can the agent Swarm help you out. And like one of the problems we often run into is founders will start on Lovable and they'll need to go to AWS eventually or something to, especially for like HIPAA, since Lovable doesn't do EAAs, and so you literally can't be HIPAA compliant on Lovable. So in situations like that, we're trying to devise a way to be able to very inexpensively migrate them across into like AWS. So one of the lessons I've learned through this process is that when AI writes code, it doesn't write it the best way very often. It is essentially always trying to ship something as fast as possible. So one of the things I often find myself doing is jumping in and constraining it and like holding it back and saying, hey, here's engineering best principles, here's a reusable component, like all of these different kind of things you'd expect of a senior engineer at a company talking to junior engineers. Part of what I learned was that I could get around that a little bit by raising it to like the next level of abstraction. So I call it the compose strategy, but essentially I give it a library of components to work from. And for the Lovable example, it would have AWS Amplify's UI components library. And it essentially is restricted to a set of components that it can use to kind of build the application over again. And I do work on those components to make them essentially resilient and be able and have them connected to AWS systems. So like the auth component is already pre-wired to work with Cognito. We don't need to rewrite an auth component to Cognito from scratch every time we work with a brand new like product or project. So standardize and compose. And then this was what I was talking about a minute ago, where I was describing how the system can kind of learn over time. I call it iterative intelligence. And here on the left-hand side, you see like how many tokens and how many errors typically a attempt at one-shotting something might take. And over time, the system is able to kind of extract from session history errors it faced on a previous project. So here I'm showing on the right-hand side, there's AWS Amplify deployments where it failed about 4 or 5 times after the migration completed. And then I got it to a successful deployment phase. I'm able to take all of that and then do a sort of swarm retrospective. I like to use the DORA metrics and things like that as well as part of the retrospective where we're trying to figure out like quality and throughput, those kinds of things. I'm trying to bake all of those errors back into the swarm's intelligence so that it doesn't make those same exact mistakes a second time. And some of that is also just like, you know, AWS Amplify might have a specific way it likes the amplify.yaml file configured, and it's a common problem that AI agents without this kind of help run into. My goal is to essentially run into a problem once every time I run into a problem. So the production reality, like cost is a real issue with swarms. One of the things we're trying to do within Rosenblatt is figure out what deploying models ourselves look like, so that maybe we can queue up all of our swarm jobs in a 30-minute increment and then deploy our own model. And it costs us like $30 and we can just pack all of our swarm session into that. That's just, or we're also looking at kind of almost like a Lambda function where you are able to deploy a model, have it serve a swarm just for that period of time that the swarm exists, and then undeploy the model. So you're not paying for the hourly costs throughout the day for those GPUs. So that's another thing. These are the kinds of things we're trying to figure out specifically. For the Lovable to AWS migration for a small app, it costed me about $20 to $50. Probably towards the middle of that range because there was some frustration on my end of like, broke this, go fix this, and it was, you know, we don't want to count all of that in with the swarm itself. Rosenblatt's SOC 2, so SOC 2 compliant. So we finished our audit this spring. We're trying to, we have a few security agents from like Vanta and things like that that we're trying to layer on top of this swarm to apply a security layer. So if the infrastructure that the swarm deploys to AWS doesn't meet kind of Vanta's strict security requirements and we get like a ping, we're also trying to do kind of a loop engineering situation where we'll recognize that that security incident for that infrastructure was detected and actually go in and start another agent to fix the security issue. So that's another kind of layer to swarms that's important. Yeah, so Rosenblatt, we're trying to build like an outcome engine. The autonomous swarm support this. How do we architect our approach to these swarms? So how do we set it up so they can compose instead of write every line from scratch? And then, of course, I just talked about the SOC 2, security guardrails. Also, happy client. And I'm gonna leave it on a quick story that I shared on my LinkedIn. So one of the things I like to do is I like to look back in history as like a military intel analyst to see what happened in the past that could help us predict what's happening right now. And part of that was, for AI specifically, was the concept of the electric engine. So when the electric engine was first commercially viable, it took 30 years before they got the full return on investment. And part of the reason for that was because they were bolting the electric engine onto steam infrastructure when it first came out. So they got maybe 2x gains, and they started to lay some people off, if that sounds familiar. There was also frustrated steam factory owners who didn't have, their factory wasn't set up appropriately to take full advantage of this fancy new electric engine. And so essentially what we're trying to do at Rosenblatt is we're trying to redesign the factory around the engine. Similar to how they did back when the electric engine came out, it took 30 years for them to get the full return on investment because that's how long until the new factories were being built. And they were redesigned around the AI, or redesigned around the electric engine as a foundation. So that's what we're trying to do now instead of waiting 30 years down the road. So that's my presentation. Thank you.
Now time for a question or two.
Especially focusing on engineering and really a very real world example of the utility sphere. I'm curious what you're encountering working with agents and large language models about really not understanding causality at all.
So when you say causality, what do you mean specifically?
It doesn't understand like anything about the real world, like very generally set up kind of information, but it won't understand anything like theory of mind, or won't understand like any of the relationship. Anytime you even like have any kind of chain of physics that is completely along anything inner circle, or it just doesn't understand anything.
Definitely.
So how do you do it?
Yeah, so the question was, how do we deal with AI's core causality management? So it sounds like physics, like not understanding like what happens when you do what, not understanding why when you do X. So one of the things I like to tell folks is that LLMs are essentially completing a pattern, and they're doing it statistically. And this is a super rough example that I try to just use to describe it. So essentially what you're trying to do is you're trying to constrain it until the stream of possibilities are within what is acceptable to you. So like, if you wanted it to understand physics, you would probably first start to give it physics equations, but you would also start to constrain it with things like an actual deterministic model of what happens when it falls. So if you give it gravity, you can give it the equation, but it also needs a deterministic constraint to hold it to the concept of gravity and effectively respond like, oh yeah, I learned over 10 attempts at this task that I'm going to fall and it's going to hurt. So that's kind of part of what I'm trying to do as well with like the posing of the app. By constraining it from an infinite, like you can write one line of code at a time to you can use this small toolbox of components and build a UI brick by brick, the total possibility space has been kind of collapsed down, and it's better able to kind of do what we're trying to tell it to do. So hopefully that explains a little bit of it, my experience at least.
I'm sorry, we're pushing for time, and then so please catch up with Sage after. And thank you, Sage. Thank you for your service. All right. Lastly, we'll have a talk from Charlie Devine, who's been working a lot with applying AI even before LLMs came onto the scene to trading and futures. So please welcome Charlie.
They just asked me tonight. I do have a pretty good voice. They just asked me tonight, but I'll tell you this. I didn't need the slides anyway. All right, first of all, background. We're a small company called Profit Fest AI. And I've got a partner that we partnered with at a fraternity at the U. And I hate to say, 47 years ago. And he was the guy that partied all night and went and aced every test in IT. Now, I was a guy in speech and communication. I was good at partying, but about halfway through college, I decided, God, what's happening with computers? This is crazy. And so I changed my whole focus. And so about 4 years ago, we ran into each other. And we had known each other through the years, and he had done a lot of things. His first job out of college as an electrical engineer was working for Rockwell, and he was designing software for the F-15 stealth software and cruise missiles. And he did it for 3 years and got bored and quit. And He's done a variety of things through the years. Well, when we ran into each other it's almost 3 years ago now, he had been working on a piece of software, and it's now been about 4 years, and he figured out, never programming AI before, and at that time, MATLAB was way ahead of Python, and it was very mathematic. So he licensed MATLAB, and he started designing a piece of software, AI software, that would predict market movement. And it sounded kind of crazy back then. How do you do it? And he looked at it, taking all the emotion out of it, and saying, this is very mathematical. And I would say about 4 or 5 months later, he and I sat down, he handed me a thumb drive, and he said, look at this, call me when after you're done looking at it. I called him the next morning, I said, let's go have lunch. And he said, I want you to look at all that data on the thumb drive. And I said, I was up all night. I was pretty good at looking at AI data. And long story short, we actually formally incorporated almost a year ago now. And we have our own AI computers. We have 4 AI computers with NVIDIA GPUs. And the last one sounds like a 747 taking off. Those metal boxes that are in these data centers, we set it up initially in one of our data guys' houses. He has 3,500 square feet, and he had to turn the central air conditioning on in January. They run that hot and that loud. And so we have a couple of computers in data centers. Why? Because what we do is we take a look at all the investments out there and say which ones correlate to predict whether or not, let's say, gold is going to go up or down today. So we're only looking at movement. We don't buy the investment. We look at NASDAQ. We look at S&P 500. Is it going up or down? Because our software profits whether the market goes up or it goes down, which is highly unusual. And we go in and come out every day. And so when we train our AI software, which is now over 35,000 lines of code in the MATLAB, and we are now in the process of converting Python, which I'll say more about, but basically what we're doing is we do over 2.3+ million data assessments on gold. On saying, okay, we got to train the AI with this data over a 5-year period. And then we come back and we say, okay, now that we've done all this training and it picks, we allow it to look at 600 possible different trading strategies, of which it picks one thread that says this is the best one. And then we make predictions each day. Each day, our computers are doing 6.8 billion data assessments in 3.5 minutes before it makes a prediction. And so we have built a ground-up platform with MATLAB. Now we're about 95% converted to Python. But basically, we look at AI as a predictive tool. And why is AI so great? Let's just, in a 10,000-foot view, it can crunch massive amounts of data in an extremely short period of time. And it's predictive. And it's only predictive if you have the right kind of software. We did test. We tested Grok, we tested Claude with Anthropic, and we tested Gemini to try to replicate what we were doing. We've done it twice in the past 6 months. 3 months ago, the last time we tested, Anthropic called us and said, you can't do this, you're crashing our system. We were crunching way too much data in way too short a period of time. The other thing we discovered when doing that is that it would make subtle changes to our model. And we're using LSTMs. Everyone familiar with all that? Well, we use 3 layers of LSTMs in our model. And it had a meltdown. And Anthropic calls me and they said, you're not going to be able to do this on any of the LLMs no matter how much you pay. Even with the new ones coming out, it's not gonna work. You gotta keep going with, and I told them what we were doing a little bit. And they said, no, keep doing what you're doing with your software. 2 minutes. But I would say this, you know, we have become so dependent on LLMs. Don't. They are not the holy grail. We tested AWS, by the way, and we had huge problems doing it. So we have our own system, and so we have a predictive AI. We are desperate. We use programmers in Europe, the US, and over in India and Pakistan. We don't want to use them anymore. We have had an extremely difficult time finding competent people from the top programs in this state. I turned down, I just said to someone, I turned down a resume. The guy had his undergrad at Stanford in computer science and his graduate degree in AI. From Stanford, middle of Silicon Valley. I couldn't hire the guy. He wasn't qualified. And I just say, there's so many opportunities here. Last thing I'll say, I can't tell you how many business people come to us asking us to help them move to AI. And they will spend and spare no expense. It's a huge opportunity for everyone here. It's the craziest opportunity in my lifetime. And I'm an old fuck, you know. But I will just say, keep doing this. Keep driving forward. There's a thirst for the services. And most of the large people with a lot of money are not using AI yet. They're afraid of it. They're fearful. I talked to a $1 billion hedge fund last week, and they are not using AI at all because they don't know what to do. So I'll just leave it at that. Anyone have any questions? Love to talk to you. Yes.
Why aren't you letting your models execute the trades? Why aren't you letting your agents execute the trades?
Excuse me?
Why aren't you letting your agents execute the trades?
Why don't we have agents execute the trade? Because they can't. They can't digest the amount of information we're feeding them to make that decision making.
I got the most important question. If I gave you $1,000 last year, what would it be worth today?
If you gave me $1,000 last year, what would it be worth today? Right now, our software is averaging about 22% per month gross profit. Per month.
I have a question on that then. So if you believe in the free market, how's the free market gonna be impacted by software like yours? Because it degrades substantially once everybody has.
All right, so good question. So one of the things that we philosophically, I pushed very hard for, even we brought in a handful of investors last fall. I made the decision, we're staying a software company that makes predictive, predictions for the investment market. And we are going to create our own hedge fund, but I have made the decision, we can scale our investments all the way down to $8,000 or less. And we're going to make it available to everyday people. And we're going to be the first ones in the US, a hedge fund, that's ever done that.
But then the market collapses. I think that's
No, it doesn't, because you have to have, so it's a good question though, because I had this a couple of years ago. So in the Chicago Mercantile Exchange with futures, there are 40,000 plus trades being made per second. So it would take a lot of time and a massive amount of volume to warp the market. But is that gonna be a problem 5 years from now? Hell yeah.
I wasn't specifically calling you out. I was
All right. So
Yeah.
I'm going to shut this down because we're out of time, but keep talking. But thank you all for coming. Really appreciate it. Thank you to all of our teams. It's a new space. I'd love to start hearing feedback. So come talk to me individually. We're also going to do a website revamp. I think we're going to put a feedback form on the website. We'll start really getting that and curating this event. Make sure that we can keep it growing. For instance, we were at Improving. It's awesome. We have big screens. We said, okay, let's unlock the screens. And I think that's been going well. So we just want to hear more of that. The brewery would also love to hear some feedback about the space. So follow up with me or go tell the bartenders they're open to hear that feedback too. But looking forward next month, we'll have a special Wild AI during Startup Week in September. So keep tuned for that. And